This time, level 1 of the time response. Should really be called step response questions. Okay, another very simple one, just like the level 0 ones. The magic number is 63%. So if we're trying to get to 591 millivolts, then 591 millivolts times 63% would be 372, and we get to 372 at approximately there, about 35 microseconds. That's probably close enough. Great. Next. Time constant, this circuit, right, here we are going from 5 volts down to 0. So if we're going from 5 volts down, the time constant would be 0.63. That would be 63% of the way from 5 down to 0. 1.85. So where are we at 1.85 volts? Answer about there, about 6 microseconds. Fine. Next. Time constant. Again, the time constant is just the resistor multiplied by the capacitor, so that's easy. Time constant to this circuit looks very like the last one. We're going from 5.4 volts. And we're going down by 63%, so that would be to around 1.998, which is about 2 volts, which is about there, 41 microseconds. Close enough. We've just done one like that. Trace on the graph shows this step response. Well, it's an inductor. You cannot change the current through an inductor instantly. That's what inductors do. They resist the change in current. So as soon as A shoots up to 1, the current through this inductor will not change immediately, which means that point there at X will remain at 0 initially. Eventually the current will start to flow through the inductor, and it will build up until you've got 1 volt flowing down through this 1K resistor, generating 1 milliamp of current. And it builds up to that slowly in a first order type of way. So let's have a look. Can't be A, because that shoots up much too quickly. What is the time constant here? Well, the time constant of an LR circuit is the inductance divided by the resistance, which would be 330 milli divided by 1K, which is 330 microseconds. Okay, 330 microseconds, we need to be about 63% of the way up, and C is the only value that gets anywhere close. So let's pick curve C. Yep. Again, it's an RC circuit, so when the step happens here, the voltage on this plate of the capacitor doesn't change immediately. It will start to increase as the capacitor is charged up by the current flowing through this 150 ohm resistor. And it will do that with a time constant of 150 times 68 nanofarads, which is 10.2 microseconds. So, which one of these is moving up? And it looks like it might get 63% of the way at around 10 microseconds. Answer D is the only possibility. Right, and so on. Level 2 gets a bit harder, but level 1, hopefully, not too bad.